Welcome to Sanjay Godat IIT and Medical Academy. My name is Uday Shankar. Today I am going to teach the motion under gravity in kinematics. See, if a body is moving under gravitational force, then its motion is said to be motion under gravity. See, you know that if you take a body, there is a gravitational force towards the center of the earth. That gravitational force is equal to weight of the body. That gravitational force is equal to weight, mg, weight of the body. We will discuss this one in Newton laws of motion. But force is equal to, in lower classes, force is equal to ma. So, ma is equal to mg. Then you will get acceleration is acceleration due to gravity. So, the acceleration of the body gets acceleration due to gravitational force, due to this gravitational force. That gravitational force is nothing but weight of the body. This acceleration is acceleration due to gravity. Okay? The weight of the body is gravitational force. That is mg. mg is equal to gravitational force. That force is ma, Newton laws of motion, second law, F equal to ma. ma is equal to mg. Then acceleration is acceleration due to gravity. On the surface of the earth, average value of g 9.8 meters per second square. Nearly, we can take this one is, for simple calculations, we are taking this one g value is 10 meters per second square. But this g value depends on place. Average value, all places, at different places, different g is there. So, if you take average value, this is nearly equal to 9.8 meters per second square. For simple calculations, we are taking g is equal to 10 meters per second square. G value changes with place to place and planet to planet. On the earth, g value 9.8, but on the moon, g value is nearly 9.8 by 6, 1/6 of the acceleration due to gravity. Now, freely falling body. What is freely falling body? Suppose if you consider a body, this is released here, body is released at this point, just released. Then here initial velocity is equal to 0. Initial velocity is 0. Acceleration. Here we have to follow a sign convention. Downward quantities are negative, upward quantities are positive. We have to use some sign convention. Downward quantities are negative. G, gravitational force downward, so G downward, so minus G. Now, displacement, body comes after t seconds, body comes to this point. Let us take this is the displacement. The displacement is minus h. Let us take this h, s is equal to h, minus h. I am following one sign convention. All downward quantities are negative, upward quantities are positive. So, here acceleration, gravitational force downward direction, so acceleration downward direction minus g. Displacement is also minus h. Now, first equation, after t seconds, body reaches this point. This displacement is h, but sign convention I am applying minus h I am considering. So, first equation, what you will get, v is equal to u plus at. When it comes to this point, here velocity is v. V is equal to, this velocity is a downward, na? So, velocity is also, we have to take negative. V is minus v. U0, V also negative, downward. Plus A minus G, T is time. So, you are getting V is equal to GT. Because I am following sign convention, because you will get some doubts when body is projected from the top of the tower. That's why, to avoid that doubts, that confusion, I am following the sign convention. V is negative. Why V is negative? It is going downward direction. Now, S is equal to ut plus half at square. This is second equation. S value is minus h. U is 0. A value is already minus g. Due to that minus, here you are getting. So, h is equal to half g t square. What is the time taken to reach the ground? The time taken is equal to root of 2h by g. Very, very important. Time taken is equal to root of 2h by g. This is time of descent. This is time of descent. Time of descent is root of 2h by g. Now, this is first formula completed. This is second formula completed. Third formula. We have the third formula. What is that third formula? V square minus u square is equal to 2as. V square minus v whole square. U square 0 square is equal to 2a minus g. S is minus h. Then v square is equal to 2gh. So, what is the velocity when it reaches the ground? V is equal to root of 2gh. This is the velocity when it reaches the ground. Now, fourth formula we have. This is third formula completed. Fourth formula. Nth second distance travelled. Sn is equal to u plus a into n minus half. Sn, displacement in the nth second, that is also negative, downward quantity. U0, a is also negative. Then you will get Sn is equal to g into n minus half. This is the distance travelled in the nth second in case of freely falling body. Suppose first second distance travelled 1 minus half. Second distance travelled 2 minus half. Third second distance travelled g into 3 minus half. In this way we can write. So, first second distance is S1. S1 is equal to g into 1 minus half. Second distance is equal to g into 2 minus half. Third second distance is equal to g into 3 minus half. In this way we can find out this value g by 2. This value is 3g by 2. This value is 5g by 2. So, ratio is 1 is to S1 is to S2 is to S3, 1 is to 3 is to 5. All G by 2 will cancel. These are the equations of the motion in case of freely falling body. Got it? Now, vertically projected up body from ground. Body is vertically projected up with some velocity u. Here I am following the sign convention. U is equal to positive u, upward quantity plus u. Acceleration downward, body is going upward, but the gravitational force is acting downward. So, due to that gravitational force, you are getting acceleration, that acceleration downward. Downward quantity I am taking minus g. Displacement, it is going upward. Displacement SC is positive. When it reaches maximum height, displacement SC is equal to h plus h. Displacement SC is equal to plus h. When it reaches maximum height, velocity becomes 0. Final velocity is 0. Final velocity is 0. Final velocity is 0. So, first equation, V is equal to U plus AT. V equal to U minus GT. This is the first equation. Are you getting this one? So, you are getting U is positive. Final velocity V is 0. Final velocity V is 0. S is, it is going upward, S is equal to plus h. But acceleration is due to that gravitational force, that is equal to minus g. Now I am writing the first equation. We have V is equal to U plus AT. So, V value is equal to, suppose if it reaches this point in t seconds. If it reaches this point in t seconds, V equal to U minus G into t. Suppose in t seconds, t is equal to Ta, body reaches highest point, then V is equal to 0. So, 0 is equal to U minus G into Ta. So, time of ascent is equal to U by G. This is time of ascent, highest point. The time taken to reach the highest point is time of ascent. The time of ascent is equal to U by G. This is the first equation. This is the first equation. Suppose body reaches this point only, we have some V. But body reaches highest point, V is 0. So, I am applying that time of ascent. Time of ascent is U by G. Now, second equation. Second equation, S is equal to UT plus half AT square formula. S is, suppose body reaches this point after t seconds, S is equal to U positive, T, A negative. This is the second equation. Next, third equation. V square minus U square is equal to 2AS. V square, suppose it reaches this point, V square minus u square is equal to 2, a is minus g, s is positive. So, v square is equal to u square minus 2gs. V is equal to root of u square minus 2gs. Suppose it reaches maximum height, v equal to 0. But it is at this point, not maximum height. It is at some distance, yes, above the ground, not maximum height. V is equal to root of u square minus 2gs. So, V is equal to root of u square minus 2gs. This is third equation completed. Fourth equation, Sn is equal to u plus a into n minus of. Sn is equal to u, a is minus g into n minus of. N minus of. Already we discussed the time taken to reach the maximum height is equal to time of ascent, capital T. That means whenever it reaches the maximum height, V0, S is h, A is minus g, maximum height, T is time of flight. We can apply the formula V is equal to U plus AT, V0, U minus G into T. So, time is equal to U by G. This is time of ascent. When it reaches maximum height, S is equal to h, V0. So, velocity is U. Here 0 square minus u square is equal to 2. A value is minus g, S value positive. That is equal to S value is h. So, u square is equal to 2gh. So, h is equal to maximum height, that h is equal to u square by 2g. So, main important formula, in case of freely falling body, time of descent is root of 2h by g. And velocity when reaches the ground is root of 2gh. These are the formula important in case of freely falling body. In vertically projected body, time of ascent is equal to u by g, already derived in the previous. Time of ascent is equal to u by g, and maximum height h, when it is projected with u velocity, maximum height reached by it, h is equal to u square by 2g. These are the important formulae you have to remember in case of freely falling body and vertically projected bodies. Now, we have to prove that time of ascent is equal to time of descent in case of vertically projected body. We know that body is projected vertically up, it reaches the height h. Here with velocity u it is projected, v is equal to 0. We already proved that time of ascent is equal to u by g. Also we proved that the maximum height reached by it, is equal to u square by 2g. Time of ascent is equal to u by g. Vertically projected up. After that, it reaches the ground. Whenever it reaches the ground, time of descent. What is time of descent? Already I wrote that root of 2h by g. That is equal to root of 2h value is u square by 2g into one more g here. So time of descent is equal to u square by g square under root. So time of descent is equal to u by g. So from that, what we can say that time of ascent is u by g I got. Time of descent is also u by g. That means in absence of frictional forces, air friction, how much time taken to go up is equal to time taken to go down. Time of ascent is equal to time of descent. So I already proved that time of ascent is equal to time of descent. Time of flight. The time taken by the vertically projected body to reach the point of projection. So whenever it is projected vertically up, this is time of ascent and reaches the same point. This is time of descent. Suppose it is projected with u velocity. Time of flight means this time plus this time. Time taken to reach here projected. Again, it comes to this point again. So, time of flight is equal to time of ascent plus time of descent. Time of ascent is u by g. Time of descent also u by g. So, total time of flight is 2u by g. 2u by g. This is the time of flight. Now, a body is projected vertically up from the top of the tower. Here it is projected from the top of the tower of height h. Then, it is projected vertically up. Here velocity is positive. We already apply the sign convention. U is positive. But acceleration, always downward direction, gravitational force, minus g. Here it is projected with velocity u. It is projected with velocity u. It is going upward and return back and reaches the ground. So, u is positive because upward quantities are positive. Acceleration, gravitational force, downward direction, A is minus g. S is displacement. Actually, it started here. It will come to here. Displacement is initial to final position direction. This displacement is downward. Minus h, minus h. See, time taken to reach the ground is t. So, suppose you want to find out v is equal to u plus at. So, v equal to, suppose u minus a value g into t. Here you will get, if it is going upward, u is greater than gt, you will get positive. Here only you will get. If it is going, after that it is going downward, u is less than gt, you will get. Then already here you will get this negative value. There is no need to apply positive and negative. If it is going upward, here only you will get the positive. If it is going downward, here only you will get this value is negative. And S value is equal to ut plus of at square formula. S is minus h, ut minus of gt square. S value is minus h, u positive, ut minus half gt square. What is the time taken to reach the ground? You have to solve this quadratic equation. That quadratic equation is what? How to get half gt square goes to that side, minus ut that side, minus h that side is equal to 0. Then if you solve this quadratic equation, you will get the t value, time taken to reach the ground. So, you solve that minus b plus or minus root of b square minus 4ac formula if you apply, you will get the time taken to reach the ground. So, what is the next point? Next formula, v square minus u square is equal to 2as. This formula, v square minus u square is equal to 2. A is minus g, s is minus h. So, v square is equal to u square plus 2gh. So, v value is equal to, you will get that u square plus 2gh. These are all 4 equations. All 4 equations I wrote. V equal to, in case of it is projected from the top of the tower vertically upward, we wrote this one, velocity. We wrote for displacement. And we wrote that third formula, v square minus u square is equal to 2as. So, I can write that fourth formula also, Sn is equal to u plus a into n minus half also. See, here, suppose if you take a balloon is going upward with velocity u. Suppose a body is released here. Its initial velocity is initial velocity of the balloon. So, first it will go upward, it will not go downward. It will go upward first, after that it will go downward. For example, if you come out from a train, then you will travel in the direction of the train for some time due to inertia. Same thing here also. This ball will not immediately fall down, just here just released. So, its velocity, initial velocity is velocity of the balloon, that is upward direction. So, it will go upward and after that it return back. It is same formula, previous formula for vertically projected body. What formula we are applying? Same formula we can apply for balloon. A balloon is rising upward and a body is released from it. The motion of the body is similar to the projected body from the top of the tower, projected up body from the top of the tower. Body is projected vertically down from the top of the tower, vertically down, not released. It is vertically downward with velocity u. Then u is negative, downward quantities are negative. This velocity, after that one, this velocity is also negative. Time is t. Displacement also negative, minus h. All are negative, downward. Acceleration, downward direction, minus g. Acceleration is always downward direction, minus g. So, v equal to u plus at formula if you write, then what you are getting now? V is negative, u is negative, a is negative. So, v is equal to u plus gt you will get. S is equal to, if you write formula, S is equal to ut plus of at square formula if you write. S is negative, u is negative, a also negative. So H is equal to ut plus half gt square. All are negative. In case of vertically projected of body, reverse. U positive, H negative, G negative. Here, there is one question. Two bodies are projected simultaneously with same velocity of 19.6 meters per second from the top of a tower. One vertically upward and other vertically downward. As they reach the ground, the time gap is. One vertically upward. Then H is equal to ut1 minus half gt square. H negative, U positive, A minus G. This T1, you can calculate this T1 by solving this quadratic equation. You will get this time T1. Now, another one is vertically projected down. Then what you can write now? H negative, UB negative, of G T2 square. Here time T2 I am considering T2 square. Then again if you solve this quadratic equation, you will get the time T2. Then this quadratic equation, you will get the minus B plus or minus B square minus 4AC by 2A. You will get that. Then T2 minus T1, T1 minus T2. T1 is more because it has to go and reaches back. T2 is less. So T1 minus T2, you can determine values, just substitute in that. You are getting 4 seconds answer you will get. Next, a balloon is going upwards with 12 meters per second. It releases a body when it is at height of 65 meters from the ground. How much time the body will take to reach the ground? So, balloon is going upward direction. Balloon is going upward direction with 12 meters per second. It releases a body when it is at a height of 65 meters. 65 meters. Now that body will go first and it comes return back. Just like this is nothing but vertically projected body from the top of the tower. This velocity is, initial velocity of the body is equal to initial velocity of the balloon. That is U positive, U is plus. It reaches the ground. This is the displacement. Initial point, final point का बीच में distance is displacement. That displacement is negative minus 65. S is minus 65 meters. And G, acceleration due to gravity downward direction, minus 10 meters per second square. Now, I am substituting S is equal to ut plus half at square. These values I am substituting. When I am substituting, you will get this T quadratic equation. You will get what you are getting now. This value is 5t square. You will get this 5t square plus 12t. 12t. Here I am doing this one. I am applying this one. See this one. S is equal to minus 65. By using that one, I am writing that equation. What is the equation I will write? S is equal to ut plus of AT square formula. S is minus 65. U is 12t minus A is 10t square. So, solve this quadratic equation. So, 5t square, you can take that side, minus 12t minus 65 is equal to 0. 5t square minus 12t minus 65 is equal to 0. Then, you solve this quadratic equation, you will get minus b plus 12 plus or minus b square minus 4ac. B square is 144 minus 4. A value is 5 into c value is minus 65. This is minus 65 by this is total is minus 65 by 2 into a 2 into 5. Then you will solve this one. So, you will get 12 plus root of 144 plus 1300. This value is 1300. 4 5s are 20. 20 into 65 minus of minus plus 1300 by 10. So, you will get this value 12 plus this value, and this 12 plus 38 by 10 you will get root of 1444 is 38. So, you will get 50 by 10, that is equal to 5 seconds. Next, a parachutist after bailing out falls 50 meters without friction. Bailing, suppose a parachutist, this parachutist is going, is in this one. After bailing out 50 meters without friction, falls 50 meters without friction. When parachute opens, it decelerates at 2 meters per second square. He reaches the ground with a speed of 3 meters per second. At what height did he bail out? Bail out meaning is what? Suppose here first he is freely falling. Then एरोप्लेन से बाहर आया, 50 meters तक parachute was not opened. When parachute opened, up to that 50 meters, he is freely falling body. After that, due to air frictional force, he decelerates with minus 2 meters per second square. Decelerates. Air friction is considered. This is not a freely falling body. It has some deceleration. Parachute is there. But up to this one is freely falling body. After that, here up to this one, acceleration is G is equal to 10 meters per second square. Is freely falling. After that, he has retardation. So, up to that, we are writing that G is equal to 10 meters per second square. I am applying the formula. V square minus U square is equal to 2AS. So, V square minus 0 square is equal to 2 into 10 into 50. Actually, if you apply the sign convention here minus 10, no? Minus 50 you have to use, minus 10, no? Minus 50. So, minus into minus plus you will get. Then you will get that this is 100,000. Now, after that, he is moving down. Now, he will get this velocity √1000. Now, he is going down with a deceleration -2 meters per second square, and he reaches the ground with velocity 3 meters per second. Again, this is the u value for us. Now, this is the v value, this is a value. Then this distance s we have to find out by using this formula. V square minus u square is equal to 2as, 3 square minus √1000 square is equal to -2 into a is 2 into s. Then we can find out the s value. By simplifying this one, 3 square minus 1000, 9 minus 1000, minus 991, but minus 4, you will get that minus will get cancelled. So, 247.45 meters you will get. So, at what height did he bail out? Means already here he bailed out. Bailed out means he jumped from the aeroplane. That is bailed out. Bail out. So, freely he is traveling as a freely falling body in 50 meters, and remaining with parachute he is going down with retardation, that is 247.75. So, total distance he travelled is 297.75 meters he travelled. Next, a rocket is fired and ascends with constant vertical acceleration. Rocket is fired. First, it ascends with constant vertical acceleration of 10 meters per second square for 1 minute. Rocket initially at rest, but due to fuel, it is going up with constant acceleration. It is not vertically projected of body, because here due to fuel a force is acted upward direction. Due to that upward force, it is going up with acceleration 10 meters per net acceleration 10 meters per second square for 1 minute. 1 minute means this time is it goes out in upward direction with fuel. 1 minute means time is 60 seconds. If its fuel is exhausted and it continues as a free particle, once fuel is completed, now it is projected a body. What velocity it will get? With that velocity, it is projected a body. It is a free particle. No upward force is there. Only force is acting downward direction due to gravitational force. Find the maximum altitude. Altitude means height reached by it. So, first of all, when rocket is fired here velocity is 0. It is at rest. Now, gases are coming out, then only it moves upward direction. So, time is 60 seconds. A is acceleration is 10 meters per second square. First 10 meters per second square. First acceleration is 10 meters per second square. Now, what height it will go? What height it will go? You have to find out. Now, what height it will go first? You have to write this distance is S. S is equal to ut plus of at square. S is here 0 plus of a value is 10 into t square 60 square. 1 minute. 1 minute it will go upward direction. That S is equal to 0 plus of 10 into 60 square, that is equal to 18,000 meters. So 18 kilometers. This is up to fuel. Once fuel is exhausted, it is vertically projected a body. So time of ascent is what time it will get? So time of ascent is, we can calculate this here velocity u is equal to 0, t is 60 seconds. Then we can write the formula. What formula you can use? V equal to u plus at. V is equal to 0 plus at. A ball is projected up with velocity u. It reaches the ground in t1 seconds. Another ball is projected down with velocity u. It reaches the ground in t2 seconds. Find the height of the tower. Find the u. Find the maximum height reached by the body from the ground. If body is freely falling from the tower, find the time taken by it to reach the ground. First, u is positive. Displacement is, it reaches the ground in t1 seconds. S is equal to minus h. A is equal to minus g for the ball 1. So, one ball is projected upward, S is equal to ut plus of at square. That is, S is minus h. U is ut1 minus of gt1 square. So, minus h ut1 minus of gt square minus of gt square. So, h value is equal to minus ut1 plus of gt1 square. This is projected up body. When body is projected up, it will go upward. For ball 2, it is projected down. U is negative, S is minus h, A is minus g. Then again I am applying the formula. S is equal to ut plus of at square. S equal to ut plus of at square. Again we will get minus h is equal to minus ut2 minus of gt2 square. Why? All are in the downward direction. H downward, u downward, g also downward. I got this equation number 2. So first equation what I got? First equation what I got? First equation I got that h is equal to minus ut1 plus of gt1 square. For first equation, h is equal to minus ut1 plus of gt1 square. Second equation I got, h is equal to ut2 plus of gt2 square. Now, multiplying this equation with t2. Multiply this equation with t1. Then, if you add these, then t1, if you add these two, what you will get that? This one will cancel. H t1 plus t2 is equal to of g t1 t2 t1 plus t2. if you add these two, then T1 plus T2, T1 plus T2 cancel, H is equal to half G T1 T2. This is the height of the tower. H is equal to half G T1 T2. Similarly, we have to find out with what velocity it is projected up. First equation I am taking, H is equal to minus U T1 plus half G T1 square. Second equation I am taking, H is equal to U T2 plus half G T2 square. Equating these two, then what you are getting now? Minus U T1 plus half G T1 square is equal to U T2 plus half G T2 square. You take this one to this side, this one to this side. Then you will get half G T1 square minus T2 square is equal to U T2 plus T1. So, half G T1 minus T2 into T1 plus T2 is equal to U into T1 plus T2. So, T1 plus T2, T1 plus T2 cancel. You will get U value is equal to G into T1 minus T2 by 2. Next, what do we have to find out? Maximum height. It reaches the ground, maximum height. So, actually, A height is H. Maximum height means we already calculated U here, U here. Then maximum height you have to find out. This maximum height is H plus this U square by 2G. This is the maximum height from the ground you will get. H plus U square already calculated, G into T1 minus T2 whole square D1 by 2 whole square by 2G. So, simplify that one. You will get 8 H plus, if you simplify this one, G square into T1 minus T2 whole square by 8G. Then H plus G T1 minus T2 whole square by 8, 1G, 1G will cancel. Now, for freely falling body, suppose from this height, when a body is released freely, what is the time taken to reach the ground? The time taken to reach the ground, you know that freely falling body, time of descent formula is root of 2h by g, root of 2 into h value half g t1 t2 by g, g will cancel, 2 will cancel, root of t1 t2. This is the time of descent. Next question, a stone is projected upwards with a velocity u. It reaches 2 points P and Q separated by distance h with velocities u by 2 and u by 3. The maximum height reached by it is. Maximum height reached by it is. You know that here velocities, I am saying that u. Here maximum height, velocity is equal to 0. Then you will get 0 square minus u square is equal to 2a is minus g into h. I am applying sign conventions. Minus g, a is minus g into h, you will get u square is equal to 2gh. But this point to this point, again applying v square minus u square is equal to 2as. V square is u by 3 whole square minus u square is u by 2 whole square, 2 into a is minus g into this height is h. This height is h. Then u square by 9 minus u square by 4 is equal to minus 2gh. 2gh. So, Simplify, if you get 4u square minus 9u square, 9u square by 36 is equal to minus 2gh, minus 5u square by 36 is minus 2gh. So, h value is equal to 5u square by 36 by 2g, 5u square by 72g. So, I want to find out from this u square I got, u square is equal to 72gh by 5 I got. Then, what maximum height you have to find out, h is equal to u square by 2g. You have to substitute the u square value already from this equation. 72gh by 5 by 2g. Then gg will cancel. It will cancel by 36. So, h value is equal to 36h by 5. Thank you.